Good news, Algebra 2 advanced students. This next video should be shorter than the previous ones. This is for chapter 1.3. Once again, read the textbook along with watching the video. There are 4 types of linear equations that I'm going to expect you to be able to solve out of chapter 1.3, and those are having a variable on one side, like this first case, having variables on both sides, the 5x and the 7x on the right, using the distributive property to figure out what x is. Again, the whole goal is to solve the linear equation. Make sure you understand that solving a linear equation means telling me what x is, evaluating x in other words. And then the last, 4th example, what do we do if we have fractions? All right, well in each of those cases there are going to be 2 key rules for solving the linear equation. Step 1. Get the variable by itself on one side. The textbook always calls this isolate the variable. I'll probably say those same words myself a lot of the time. How do you do that? You undo PEMDAS. What do I mean by undoing PEMDAS? I mean do it in the opposite order. So if I'm working now in the opposite order from right to left, then I'm going to deal with addition and subtraction first, then multiplication and division, then exponents, and the last thing that I'm going to undo or unwrap is the things inside the grouping symbols, usually the parens. So undoing means like unpeeling an onion from outside in. And if you think of the thing inside the parens as the thing that's most closely inside the fort, most protected in other words, you're going to get rid of the outer layers first. So let's look at some examples. Easiest example that we're going to deal with is this case here where you only have one variable. You're trying to figure out what x is. So again, you've got to get that variable by itself. Well, you're going to get that variable, which is the x, by itself by moving things out of the way. You're not going to move the 3 first, though, because that's being multiplied. You're doing the opposite order of PEMDAS. So you're going to move the 9 first. Move that negative 9 over. Oops, sorry. And you're going to have negative 12 now on the left. And the right's just that negative 3. Now you can divide off that negative 3 from both sides, and you'll end up finding that x equals 4. Let's make sure that made sense. Here are 2 examples for you to try. When you're ready, hit the pause button, and when you come back, I'll explain the answers for both of these. Okay, I'm going to assume that you've done that. Let's look at the one on the left here. You moved the 2 over first, I hope, and got 5x equals 15. Then you divided away the 5, and you got x equals 3. Now on the right side, you remember you had 6 minus x. You want x by itself, so you've got to move that 6 over. Well, it's a positive 6. You're going to subtract 6 from both sides. Now you're going to have negative x equals, well, 4 minus 6 is negative 2. Well, if that's the case, then divide both sides by negative 1, and you're going to end up with x equals 2. Remember, you can always plug the answer that you get back in and make sure it made sense. Put the 2 in here, 6 minus 2, sure enough, that is 4. Now, what about if the variables are on both sides? Well, I'm going to get the like terms together. So I'm going to move the 5x and the 7x together on the same side. I'm going to combine all the variable terms, like it says here, and then I'm going to do what I'd said before. Isolate the variable which is now by itself by undoing PEMDAS. I should say isolate the variable which is now just on one side. Okay, so I moved the 5x over this way. Why did I choose to move the 5x this way rather than the 7x that way? Because I'd rather not deal with negative variables if I don't have to. The last problem that I solved on the previous slide only became a little bit of a pain because I had a negative x. I'd rather not have that. So I move 5x over this way. That means I've got to move the term that doesn't have a variable to the other side. Now I'm going to have 20 on the left, right, because I've got 11 plus 9. And I'm going to have 7x minus 5x, or in other words, 2x on the right side. And so, of course, x becomes 10. Once again, if you want to double check, you can always plug 10 in for x. You should find that the equation works. This time just one example for you to try. When you're ready, come back and I'll show you the answer. Okay, again, I'm going to assume that you've paused, solved for x, and are ready to check your answer against mine. I moved, in this case, the smaller x term this way, and I got 4x, which meant I had to move the term that didn't have an x from the left side over to here. So I get 4x equals negative 12. Divide it by 4, and I end up with x equals negative 3. Sometimes x is going to be inside parens with a number outside it that has to be distributed. In this case, this is a fairly ugly problem where I've got x's on both sides, and I've got a negative outside one of those parens. Well, distributive property means I'm going to distribute the negative to both of these. I'm going to distribute the 2 to both of these things in the parens. So on the left side, I've got negative x now minus 1, and on the right side, I've got 6x minus 2. Okay, I'm going to put the negative x together with the 6x. That means I'm going to move the negative 2 over here. And I end up with, on the left side, 1, and the right side, 7x. Divide both sides by 7. Whoops, and I've got the wrong answer written there. I guess I didn't finish writing my answer. X is equal to 1 over 7. Okay? 2 for you to try. These are a little more challenging, but not a lot more challenging. Hit the pause button when you're ready to come back. I'll work through the answers for both. Okay. This time the right side problem was the easier of the two, so I'll talk about that one first. I distributed the half, and on the left side I got 2x plus 5. The right side stayed the same as it was. Then I put the x terms together. I'd rather not deal with negative x terms, so I moved the negative 3x over this way. I got 5x. That meant I moved the 5 over here, and 5 minus 5 is 0. Well, if 5x is 0, then x must be 0, right? Divide by 5, 0 minus 5, 0 divided by 5 rather is 0. And on the left, a little more complicated. I distributed that 2. I got 14 minus 2x. I distributed the 6, likewise. I put the x terms together, they ended up on the right side, and I got 14x. I put the 6 now over to the left. 14 minus 6 is 8. Well, that unfortunately means that I've got to divide by 14 on both sides. And so what do I end up with? 8 over 14, or in other words, 4 over 7. It's a little bit of a pain to confirm this, but if you do plug in 4/7, you'll find that these two left and right sides do equal each other. 4/7 is the right answer. I wouldn't have been terribly disappointed if you left the answer as 8/14, though. Now, last situation, fractions. What do you do when you have fractions in an equation? Well, in this case, start by finding that common denominator. And then, like I've been saying all along, isolate the variable by undoing PEMDAS. I'll probably be saying this throughout the year, this line right here. All right, well, what's my common denominator for 3, 4, and 6? Well, the lowest common denominator is 12. It doesn't matter if you didn't think of that lowest one. The problem would have been solvable if you'd picked 24. It would have even been solvable if you'd decided, well, the only common denominator I can think of is if I multiply 3 times 4 times 6, and you'd come up with 72 here. It would have been much more of a pain to deal with 72, I admit. I'd rather deal with the lowest common denominator just to make my life easy. Okay, so I know that I'm going to convert everything to 12. 1/3, if I change it to 12, becomes 4/12. Why? Because that 3 in the denominator, if I'm going to make that a 12, it happens because I multiply by 4. So then I multiply the 1 times 4, and I've got 4/12. I did the same thing in converting everything else here. And I did have to convert everything, even this x. It became 12 over 12x. Okay, now on the left, I've got an x, and on the right, I've got an x. I'm going to put these together. This is the smaller of the two, so I'm going to move it over this way. That means the term that doesn't have x has to get out of the way and come over to this side. Once I move those around the way I'm talking about here, I'm now going to have, on the left side, 5/12, and on the right side, I'm going to have 8 over 12x. How do I solve for x now? Well, I could divide by 8/12, but an easier way is to multiply by the reciprocal. So I'm going to multiply, well, I think it's actually the next slide that I do that on, by 12 over 8. So now I'm doing 12 over 8 times 5 over 12 equals, and the only thing that's left on the right side now is x. So what do I do next? Well, let's just use another color for the heck of it. Cancel those 12s, and I'm left with 5 over 8. And that's my answer. X equals 5/8. Here's one for you to try. Okay, I'm going to assume that you paused and you solved this one. Here's how I solved it and the answer that I came up with. First of all, and this one is a challenging problem, I multiplied, or distributed I should say, the 2/3 through. 2/3 times 3x is 2x. 2/3 of 6/5 becomes 12 over 15. You might have said it became 4 over 5. That would have been fine also. Let's just say that I left it as 12 over 15 because actually I did. 1/5 times 5x is just x, but 1/5 times -1 is 1/5. Now, as I say, I ended up using 15 as my denominator. If you'd used 5, the problem was actually easier to deal with, but I'll show you what to do if you did use 15. You've got to get the x's on the same side. Oops, I'm actually going to go this way, aren't I? So I move this x over by subtracting, so my left side is now just 2x minus x, which is 1x. And I move the 12 over 15 over this way, and so x is going to be equal to -1/5 minus 12 over 15. As I say, I had to convert to a common denominator. I got -3 over 15 minus 12 over 15, or in other words, -15 over 15, or -1. If you'd plugged that back in, you would find that it works just fine. How would you ever use this? Well, actually, the skills of chapter 1.3 come up again and again in life. A perfect example is working, with sales tax. The textbook has picked Pennsylvania as its example, where the sales tax is 6%. If you got a bill that had $1.32 for the tax, and you wanted to work backwards and make sure that was correct, how much did the stuff that you bought at the music store cost you? I set the problem up this way. 0.06, in other words, the tax rate, times the total bill, that's the mystery, came out to be $1.32. Okay, well, so then that total bill is 132 divided by that 0.06, or in other words, 22 bucks. So you spent $22, and then another $1.32 was added on as tax. Here's a last thing for you to try, and this is a perfect example of where you would use the lessons of chapter 1.3 in real life. Okay, I'm going to assume that you hit the pause button and you worked on this word problem, and now you're ready for me to show you how I got my answer to it. I said that the broker got $18,000 even if she didn't sell any house. But every time she did sell a house, she got 0.04, or in other words 4%, times the value of that house. And the grand total of all of that work she did in the year turned out to be $55,000. Okay, well, I want to find out what that value is for the houses she sold. So I move the 18,000 over first, don't I? And I get 0.04 times that value equals 55 minus 18 is 37,000. And what's left now? That value is going to be 37,000 divided by 0.04, which turns out to be $925,000. That's the value of all the homes she sold. All right, that's it. Here's tonight's homework.